Hello. In part 1 I showed how I made a layered 2D puppet in Krita with additional textures for normal maps, ambient occlusion, roughness and metallic. After that I animated the illustration, exported the images and made a sprite sheet. This video will show how I did that. I'm not sponsored or paid by any of the software I mention and my opinions are my own. Moho is a professional animation software for animating 2D, raster and vector images with an advanced bone rigging system. This is not a full tutorial. If you want to learn more about how to use Moho, you will need to watch the official tutorial series for the program on their YouTube channel and read the manual. To start with, I am showing my Squirrel mascot project which I animated in Moho. As well as animating my character with lip sync in Moho, I can use it in a program called RahiTuber by turning the animation frames into sprite sheets. It is a rigged character made of image layers. I have different layers for the mouse shapes so that it can be used for audio lip sync, which is a feature built into Moho. I won't be going over that in this video, but perhaps in a future one. Here I imported the PSD file I exported from Krita in the last video. I altered the project settings by going to Project Settings in the File menu. I set it to 1920 by 1080 pixels because I mainly use Moho to make animations for videos, and I wanted some space around the character to make sure all the movement was captured, but custom sizes can be used. Rigging is a process where you draw out bones for your image layers. It can be an iterative process for each new project. Sometimes you have to alter the art to better fit the rig or suit the animation you need. Any changes to the PSD file will update in Moho, but I found that if I added new layers, sometimes they imported in the wrong order, so that is something to be aware of. My first rig attempt made me aware of changes and additions needed for the layered art. There were areas that needed more overlap coverage, like the body behind the head, and I made alterations to the scarves and the hat so that they would be easier to rig. I had to add a leg layer behind the left foot and separate the waistcoat from the body so that it would overlap the body but go under the waistcoat. I made quite a few edits and redid the rig a few times before I got it working the way I wanted it to. The way you're going to rig will be dependent on how the image is layered and what sort of movement you want to achieve. The movement will be dictated by the layers of the image, so it's a good idea to plan it out roughly first before working on a fully rendered artwork. After changes to the layers, I rigged this character and animated it a little bit in order to test the rig worked properly. I've applied subtle physics to the hair and the tail. The eyelids is just a switch layer, so there's an open and close one. The pupils move is a switch layer as well. Mouths is for the colour layer, and it's a switch layer. After I was happy with the colour layer rigging and binding, I found the art layers for the normal map group and then the orm map group to the same bones. I copied and pasted the switch layer keyframes for the eyelids and the pupil movement to the normal map and the orm switch layer timeline because I want them to sync with the colour layers. Here I'm moving the last keyframes of the animation, which match the keyframes on frame 1 because I want it to loop to frame 120. I did this so that it would work better for the sprite sheet. It will be a 10 by 12 sprite sheet, so it will fill the entire grid now. I need this to happen because empty frames will look wrong in Bluff Titler. I export the layers in Moho. I set it to render half dimensions because I don't need it bigger than that for the sprite sheet packing, and I make sure not to pre-multiply the alpha channel. If you know how big you want your sprite on a sprite sheet, a good rule of thumb, unless it is pixel art, is to make it twice the size you need it and then halve it on export. Pixel art is different because you have to draw it very small and then it's the size it is. I export each material group in turn, showing the one I want to export and hiding the others. You have to do export animation every time for each material, not export with the same settings. If you do export with the same settings, you will overwrite the frames you did last time, which will really annoy you. So you need to set a different folder for each of the texture sequences as well. So now I've got the exported frames for the normal map. I want to put an n suffix on the end after the number sequence. I do this with xenview mp as a batch rename operation. Then I cut and paste them into the colour folder. For the method of texture packing, I'm going to show I need the names of the files for the normal map and the colour sequence images to match. So I use batch rename in xenview so they all match. We'll still have the n suffix at the end of the number sequence for the normal maps, so that the program I use to pack the sprites will know they are normal maps. I use a program called Texture Packer by Code and Web for sprite packing. Texture Packer is a program for packing sprite sheets. I've had it for a few years, and I bought a lifetime license a while ago with another program called Sprite Illuminator and one that does 2D physics, which I've never used. Because I halved the size of the images in the export already, and that is the size I want them to be, I can set the scale to 1 in Texture Packer. If I wanted them to be smaller, I could set them to a different scale in this program, but I think it's probably best to scale them to the size you want first to preserve the quality. I want to keep the art a good quality for the sprite sheet, and I make sure pre-multiply alpha is not on. This program has a setting to use the normal map suffix n I made earlier to differentiate between the normal map and the colour. It will save out 2 sprite sheets, one for the colour and one for the normal map. You do this by pressing Publish Sprite Sheet. To pack the ORM images as a sprite sheet, you can just delete the colour and normal map images from the left layer menu in Texture Packer, and then drag and drop your ORM textures to use the same settings as the project. Untick the normal map option and remember to change the file name for the export before you click Publish Sprite Sheet. It is probably a good idea to save the project file so that you don't have to remember all the settings again in the future. In this section, I'm adding a sprite sheet to Bluff Titler. I've added it with the picture plane import. Then to get the animation working, I use the film strip frame property and set the horizontal and vertical number to what my sprite sheet is, 10 by 12. Then I set the frames per second property to use 24, which is the frame rate I used in Moho. I apply the PBR texture sprites I packed with the PBR effect. The normal map will enable dynamic lighting, and the materials define how shiny or rough the surface is and whether there's any metallic areas or not. The light is still affecting the layer without the PBR materials, but it still looks flat compared to the one with the PBR materials. I got the idea to pursue this sort of technique several years ago. I saw an old Moomin cutout animation which inspired me to try and recreate that 2.5D look with digital media. This is why I've been trying to use these techniques for years. Blender can import image sequences and show them as animations. You can have animated textures on your shaders as well. You go to Add Image, Mesh Plane, and then you can select an image or a sequence of images. I'm going into the shader editor and I'm going to set it as an image sequence and put the amount of frames I want, which is 120, and set it to cyclic. Auto refresh is a good option to have as well. It will play in the timeline. The first time the images will load a bit laggy, but they'll load faster after Blender has cached them. Now I'm adding an image texture for the normal map images. Now I'm adding the ORM images and linking them to a separate colour node after setting them to use non-colour. The green goes in the roughness, the blue in metal, and the red is for AO. To add the red channel, I added a mixed colour node set to multiply. The base colour goes into the first slot and the red channel from the separate colour node into the second. The output of the mixed colour node will go into the base colour of the principal BSDF shader, and the factor is set to use 1 for the multiply. Blender doesn't really need to use AO materials, but I thought I may as well do that since I'd made one. I'm setting up a camera and I want to rotate the image plane so that it's visible from the front instead of the top. The lighting will work better that way. Image planes do have some limitations compared to 3D models with lighting. You can't really use rim lighting, for instance. The other thing you can have is an emission map if you wanted areas on your character that lit up. It looks slightly nicer in cycles, but Eevee will load and render a lot faster and it looks very similar. Not different enough to spend half an hour rendering all the frames anyway. Here I'm showing an add-on that lets you add sprite sheets to Blender called Sprite. I found this add-on on Superhive and it was only $1. It can build and load sprite sheets in Blender. I've also added the PBR textures to the sprite in the shader for the colour base sprite sheet. I did that by importing the sprite sheet for the normal map and the ORM map as sprite sheets with the add-on. Then I copied and pasted the nodes for those textures to the colour based sprite shader and connected them to the appropriate slots. After doing all of that, I have a few thoughts. The process of creating the separate normal map parts in the first video was a bit annoying because I had to export layers to use them in Lighter and Sprite Illuminator and then re-import them again in Krita. There was a lot of back and forth process between those programs. I wish there was some sort of bridge between the programs that updated changes dynamically, or a way to integrate those processes somehow. Making all of the material groups for the colour layers was extremely time consuming, especially as I had to add layers and change layers later on. It would be great to have a program for 2D images that work like 3D Coat does for 3D painting, have smart materials and channels for roughness and metal. I understand this is not likely to happen, I just thought I'd mention it. Something I could have done to help the process in Krita would have been to clone the colour and normal map groups and set these up in group layers for the orm textures. I tried this just to test it and it seemed to work. This would have the advantage that only the colour and normal map layers would need to be updated rather than manually copying every layer like I had done before. I've never found a need to use this feature in Krita before, and I was just trying to figure out how to do it in the previous video, so I hadn't thought to do that at the time. Once I had all of the layers done, I was happy with the rigging and animation process though. The sprite sheet method was useful for importing the animation and setting it up faster than the image sequence method in Blender, and it didn't lag. Thank you for watching.